Okay, folks, we're coming to this part here, stereoisomerism of alkenes. Okay, so why are we talking about alkenes, right? What about them? Okay, see, when you have an alkane, right? Let's say you have ethane. Okay, when you have ethane, the two carbon atoms are bonded by a single bond. Okay, so this is a single bond. This single bond, it can rotate. That means you can rotate 100 and maybe I should say 360 degrees. It can spin. Okay, so it can rotate along that line. So what does that mean when it can rotate? What does that mean? It basically means that, let's say when you draw, right? Let's say you put a chlorine over here. Okay, you put a chlorine over here, and then when you draw, you put a chlorine up here. Okay, you will say, this is not the same, because this one the chlorine is at the top, this one the chlorine is at the bottom. Is not the same. But you must realize that this single bond can rotate. Okay, it can rotate. So which means that this chlorine can come down here, and this hydrogen can go up there. So which means that both sides will look exactly the same. That can happen. Okay, but when you have a double bond, okay, when you have a double bond, that cannot happen. You see, like for example, in this case here, see over here, this is called butene. So both of these images that you're looking currently, they are both called butene. Butene. Okay, so butene, if I write it as an equation, it will be CH3, CH, and then another CH, another CH3. That's how butene will be written. Or if I want to put the double bond there, then I put the CH3, CH, the double bond, CH, CH3. Something like this. When you look at this image over here, if you look here, you see in this first image, the CH3 is at the bottom here, and the other one, the CH3 is up here. Okay. And in this second image here, the CH3 is up here and the other CH3 is up here. That means it's facing each other. And this one is in the opposite direction. They are not the same. Because this is a double bond, this is double bond, right? It cannot rotate. Okay, it cannot rotate. It's like your car wheels, they are made up of just one axle connecting the two tires, so it can rotate. But if you had two axles attached to the same tire, the tire won't be able to spin. Okay, same thing over here. Because there is a double bond, the carbons cannot rotate. They cannot rotate. That means they are attached there and they're stuck over there. That's it. They cannot move. So which means that what is written here as trans-butene and cis-butene are not the same. They are not the same. So for example, let's say if you had an enzyme active site, okay, you had an enzyme active site that looks something like this, right? That looks something like this. So what you notice is, if the enzyme active site looks something like this, let's say something like this, right? Only trans-butene can come and get attached to the active site. Cis-butene cannot attach itself because there is only one depression over here. So it only allows one CH3 to sit in. The other CH3 cannot sit in. So in the case of cis-butene, if it tries to sit in the same active site like this, imagine if we just take this part over here, right? So let's say this is the active site, correct? This is the active site. So this active site, that means it can sit. And now you see this part cannot sit because it's supposed to be a straight line, correct? So which means that cis-butene cannot sit in that active site, but trans-butene can. So what I'm trying to explain to you here is, although they look the same, their name is the same, they are not exactly the same. Okay, so one is called trans-butene. Trans means Trans basically means transatlantic. That means opposite direction. These two groups are opposite of each other. The two methyls are opposite of each other. Or the two hydrogens are opposite of each other. This is called trans. Cis basically means the same groups are facing each other. So this is called cis. Okay, the hydrogen and hydrogen is facing each other is called cis. Trans means that the similar groups are facing opposite of each other. That's what trans basically means. Okay, now here we can still use cis and trans for this one. Okay, but slowly it's going to get more and more complicated. In this image over here, this is called 1-bromo 2-chloroethene. Okay, let's say here you see the hydrogen is over here and the other hydrogen is over here. In this image here, it was quite easy because we were dealing with methyl groups and hydrogen, so you can see it. Here it becomes a little bit more challenging. There is no methyl group, there is no hydrocarbon. So what we do is we look at the hydrogens. You see there's one hydrogen here and the other hydrogen also in opposite direction. So this is called trans. And in this image, this hydrogen and this hydrogen is facing each other. So this is called cis. Okay, so I'm going to try to give you an example. So let's say we have a hydrocarbon, something like this, like CH3, CH2, CH, and then CH, and then CH3. Okay, something like this. All right. Or if we try to draw this, if I draw this out for you, it looks something like this. Okay, there's a double bond here. Okay, so this is a CH3. So CH3, 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 CH, CH, and then there's a hydrogen here and there's a hydrogen here. So, all right, what's the name for this? So how many carbons do we have? How many carbons do we have? We have 1, 2, 3, 4, 5. We have 5 carbons, right? So, and then double bond is at position number 2. So this is called pent 2 in. Okay, so this is called pent 2 in. So now, since there is a double bond, definitely you might, okay, I shouldn't use the word definitely. There's a very high possibility that there's going to be a cis and trans configuration. So let's say if your textbook or your exam says, hey, can you please draw the cis and trans images of pent 2 in? Okay, draw the cis and trans images of pent 2 in. So how do you do this? So what you do is, it's quite easy. What you do is you keep this part fixed. Okay, you keep this part fixed. So what I'm going to do is I'm just going to draw one image over here with the C double bond, and I'm going to draw another image over here with C double bond. Okay, then what I'm going to do is I'm going to identify these groups here. Let's say this group here, and then I'm going to identify this group over here and then this group over here. Okay, so what I'm going to do is, in my first example, I'm going to put the hydrogen like this. I'm going to draw it like this. One hydrogen up here and the other hydrogen up here. Then I'm going to draw this CH3. I'm just going to draw it like this, CH3 like this. And on this side, it's going to be CH2, CH3. Ta-da. So I put this together. Okay. On this image here, what I'm going to do is I'm going to put this hydrogen up here. And then I'm going to put this hydrogen down here. And I'm going to put a methyl up here. And on this side, I keep everything as it is. So you see, now what I have done is, in this first image, the hydrogens are facing each other. In the second image, the hydrogens are opposite of each other. So this is going to be called cis, pent 2 in. And this is going to be called trans, pent 2 in. Okay, got it? So one is going to be called cis and the other one is going to be called trans. Okay, sorry, trans but pent twin. So you have cis and you have pent. So that's how, if you have been asked to draw the cis and trans configurations, that's how you're going to do it. Okay, so that would be quite straightforward. Let's say if we do another example, let's say we have something like this. Oh, we cannot have cis and trans. Let's say if there's a hydrogen over here, right? If it's like this, you cannot have cis and trans. So like for example, let's say if you had this guy here. Let's say you had this guy over here. This guy is propene, right? Propene. So if you try to draw this as what I told you just now, okay, you just focus on this part here. Just focus on this part. Okay, we focus on that part, and then you have a C double bond O, and then you stick one hydrogen up there, you stick one hydrogen down here, another hydrogen up there, and the CH3 down here. You cannot have cis and trans because you cannot have two of the same groups attached to the same carbon. You cannot. So meaning if you had something like this, let's say if you had a double bond like this, and then there was a CH3 over here and another CH3 over here, you cannot have cis and trans. It cannot happen. Okay, so you cannot have the same group on the same carbon side. That means the cis and trans configuration will not work if it's like that. Okay, so let's say we had something a little bit different. Let's say something like this. Okay, let's say we put another one here. Okay, so now let's say if you're asked to draw the cis and trans configurations for this one. So currently what we're doing is we are dealing with hydrocarbons only, hydrogens and carbons. We don't have anything else. So again, what we're going to do is we're going to focus on this part here. Okay, we keep this part as it is. So we draw one image over here, and then we draw another image over here. So what we're going to do is in the first image, we put the hydrogen up here, hydrogen up here. Second image, we put hydrogen up here, and the other one hydrogen down here. Then what we're going to do is we're going to put that C2H5. Okay, so this group is C2H5, right? Okay, we're going to put C2H5. You can do that. It's not a problem. Okay, and then on this side, we're going to do the same thing, C2H5 on this side. So now here we have C2H5 up here, and then here we have C2H5 down here. So obviously, so what is this guy called? 1, 2, 3, 4, 5, 6. This is called hex. What is this? What's the name for this guy? Hex 3 in, right? Hex 3 in. Whichever way is 3 lah. So if I go from here, it's 1, 2, 3. If I go from here, it's 1, 2, 3. So it's hex 3 in. So this image, this is going to be cis hex 3 in, and this is going to be trans hex 3 in. Okay, so that's how we come up with the cis and trans configurations for hydrocarbon. So in this case, this is like a hydrocarbon. It's mostly made up of hydrogen and carbon. Then you come to a situation where it gets a little bit more complex, where you have E and Z isomers. E and Z isomers. Now, E and Z isomers, E and Z. So this is called it's part of the Cahn-Ingold-Prelog, which is called the CIP rule. Okay, so you'll come across, when you see the word CIP rule, this is what it is. Now, the CIP rule, or the Cahn-Ingold-Prelog law, or the rule, is used more because you see the cis and trans configurations cannot be used in all circumstances. Okay, sometimes it doesn't work. So IUPAC has come up with a new method, and that's called the E and Z configuration. E is a German word for entangent. Z is Zusammen. Entangent basically means on the opposite side. Zusammen or Z means on the same side. All right, so it is useful for hydrocarbons which are for hydrocarbon compounds which are very complicated. Like you see, like look at this image over here. Okay, if you look at this image over here, it's going to be a bit difficult for us to use cis and trans, because you see, if there's hydrogen here, there is no hydrogen on the opposite side, correct? Here we have a hydrocarbon, but there's no hydrocarbon on the opposite side, so we cannot use this rule. But this rule is actually very easy. So how does it work? Okay, how does it work? So what I'm going to do is I'm just going to give you an example. Okay, so let's say you have an extreme case like this. Okay, let's say you have an extreme case like this. So let's say you have an iodine over here, let's say you have a hydrogen over here, let's say you have a chlorine over here, you have a bromine over here. Okay, and you want to distinguish this from this guy over here. This is Br here, this is chlorine here, let's say this is iodine, and this is hydrogen. They are not the same. They look the same, they are not the same. So what is the name for this guy? This is an ethene. This is an ethene, so this is going to be called bromo chloro iodo ethene. Wow. Okay, such a long name for a small molecule. Bromo chloro iodo ethene. That's the name for both of them. So they are both called this. But now we need to differentiate between them. We need to differentiate between both of them. Which one is cis and which one is trans. So now we're going to use a CIP rule. Now the CIP rule uses atomic numbers. So what you're going to do is you're going to cut this molecule into half like this. Okay. So then you're going to assign the atomic numbers for these atoms. Like hydrogen atomic number is 1. Iodine is 53. Chlorine is 17. Bromine is 35. Okay. Again, this is 53, this is 1, this is 35, this is 17. Atomic numbers. So once you've assigned atomic numbers, what you're going to do is you're going to look at this number and you're going to look at this number. So a simple question, which number is bigger? Okay, let's say 53 is bigger. We put a 1 over here and we put a 2 over here. 17 and 35, which number is bigger? 35. So we put a 1 over here and we put a 2 over here. So now when you do this, you notice that, what do you notice? You notice that 1 is facing 2, 2 is facing 1. The number 1 is facing 2 and 2 is facing 1. So this means they are in the opposite direction. You see 1 and 1 over here is in the opposite direction, right? So this is called E bromo chloro iodoethene. And if this is in E, this is going to be Z bromo chloro iodoethene. That's going to be the name. Okay, so E means that numbers are facing each other. Sorry, E means the numbers are opposite of each other, like in this example here. And Z or Zuzamen means together, meaning those numbers are facing each other. So like for example, we know this is 1, this is 1, we know this is 2, and this was 2. So 1 and 1 is facing each other, 2 and 2 is facing each other, so it's called Z. Z means Zuzamen, and Zuzamen means together. So you can use this E and Z configurations for everything else as well. You can even, instead of using cis and trans, you can use E and Z, not a problem. Okay, so E and Z is what IUPAC wants you to use actually. So E and Z can be used for all situations, or nearly all situations, but cis and trans you can't. Like this example here, it'll be difficult for you to use cis and trans because there are no hydrocarbons attached to the carbons with a double bond. Okay, so that will end this part here. So that's basically what we have here. Okay, all right, thank you.